learning about SQL aggregate functions that can be built in CDS views. So let's understand the concept of SQL aggregate functions with an example. Let's say we have the purchase order item table, and this table has the fields purchase order number, material number, and the quantity that was ordered from the vendor. Let's go ahead and fill in some random data here. So we have the material M1, it was ordered twice in purchase order 451 with a quantity of 4 pieces, and thereafter in purchase orders 452 with a quantity of 7 pieces. And similarly, we have another material called M2. This was ordered thrice in purchase order 453 with a quantity of 5 pieces, purchase order 454 with a quantity of 1 piece, and finally in purchase order 454 with a quantity of 9 pieces. Now, if I were to set up a projection view by building a normal CDS view entity on top of this table, and in the view output, if I had included the fields material number and quantity, my view output would look something like this. I would get 2 records for the material M1 corresponding to these 2 records in the data source, and I would get 3 records for material M2 corresponding to these 3 records in the data source, right? So in effect, all records from the database table are being reported. There is no summary, there's no summarization or aggregation going on, right? So whatever is there in the database table gets reported as is. Now let's say I want to see my output a little differently, right? I do not want to output the information like this as individual data records. Instead, I want to first group the records into collections based on the material number, which basically means that all records having the same material number should come together into collections. So these 2 records for M1, they come into one collection, and these 3 records for M2, they come into another collection. Each of these collections is going to be called an aggregate, right? And then within each aggregate, what I want to do is I want to find the total or the sum of the quantity column. And then I want to report the result material wise. So what this basically means is I want my output to look something like this. I don't want to see 2 records for the material M1 with the quantity of 4 pieces and 7 pieces. Instead, I want to aggregate that into one record. So I just want to see one record for M1. And in the quantity column, I want to see 11 pieces, which basically, this is basically 7 plus 4, so 11. And for the other material, M2, again, I don't want to see 3 records in the output. I just want to see one record in the output for the material M2. And under the quantity column, I want to see the consolidated value or the aggregated value of 14 pieces, because that's the total of the ordered quantity for this material across all sales orders, right? So if I were to summarize it, what are we doing? For each material in the data source, I want to see the aggregated total quantity ordered across all purchase orders, right? So this kind of an output is what we call as an aggregated output. So we do not simply output the data records from the data source as is. Instead, we first collected them into groups called as aggregates based on some grouping criteria. And then we aggregated a particular column, the ordered quantity column, right? So based on this example, let us formalize a few concepts now, all right? From an architecture standpoint, SQL aggregation basically means you build a CDS view on top of a data source, an underlying data source, and within this CDS view, you group the records into aggregates based on some grouping criteria. And once they're grouped into aggregates, you perform some sort of an aggregation function on one of the columns, all right? Now, in our example, we had summed up the ordered quantity column, right? So this is the first important concept that we should know, what aggregation basically means, right? And the next important concept that we should know is the grouping criteria. Now, I had grouped my records based on material number. So basically what that means is that all records with the same material number would land up in the same aggregate. Um, you can of course have more than one field in your grouping criteria, right? In our example, we had just one, but there could be more than one, and there would often be more than one field in the grouping criteria. The next important concept to know is the aggregate function. Now, in this example, once we had set up the aggregates, we had used the sum aggregate function on the ordered quantity column, right? So we had calculated the sum of all the ordered quantities across purchase order items. There are other aggregate functions that can be used, and we will see them as we go along in this video. And finally, we should also know the concept of the aggregated column. In our example, we had applied the sum function on the ordered quantity column, right? So the quantity column, ordered quantity column, is the one that was being aggregated, and so we refer to it as the aggregated column. Now let's try to implement some aggregate functions. I'll explain the business use case to you. We have here the sales order item table, VBAP, and this table is keyed on the sales order number and the item number. In each of the sales order items, we have the material that was ordered by the customer. And if I select this material column and apply filter, so using this set filter, and we press an F4 over here, we can see that um, the 55 entries found. You see this message over here, 55 entries found. So this basically means that there are 55 unique materials that are present in this table under the column material number. But the total number of records in this table is 5,845. Now this obviously means that there are materials that have been ordered more than once. So next we have the net value column. This is the price that the customer is going to pay, the net value for this material. This is the currency for this amount. And then we have the user who had actually created this sales order item. All right. Now this table right here, the VBAP, this is going to be my underlying data source. All right. And on top of this table, I am going to create my CDS aggregation view. The CDS aggregation view that I will create on top of this table is going to read this data source and then aggregate some information. All right, that's why it's the aggregation view on top of this underlying data source. So let's talk about the output of the aggregation view that I'd like to see. Let's say I want to calculate the aggregate sum of the net value column based on material number and currency. All right. This means I want to first group all the records that I have over here into aggregates based on material number and currency. So this basically means records with the same material number and the same currency come into the same aggregate. And once these aggregates have been built, I want to calculate the total of the net value column. So this is my aggregated column. I want to calculate the net value column within each aggregate. All right. Now, you can actually visualize the aggregates from here, from within SE11. And the way to do that is, let's say since I'm aggregating on now, you can actually visualize your aggregates here in SE11, right? So our grouping criteria is material and currency. So I'll just select the material and the currency columns and I'll sort them based on this. Now you can see these records over here all of them have the same material ZPrinter01 and the currency USD. This means that this is going to be one aggregate, right? And then these two records over here, they have the same material ZPrinter01 and the currency Euro, EUR. So they would form part of the next aggregate. Similarly, all these records over here, they have the material number TG22 and the currency USD. All these will form part of another aggregate and so on and so forth. So SE11, this is a good way to be able to visualize how your aggregates will be looking like at the end of the process. Okay. Now, you may wonder why we are using currency as a grouping criteria. This is because if you notice, if you have a look at your data, you can see the same material can be ordered in different currencies. So for example, if you look at this material ZPrinter01, it has been ordered in the US dollar currency and also in the EUR currency, Euro currency. If I were to use only material number as my grouping criteria, then all of these records would land up in one aggregate, and I would end up adding a euro amount with, I would end up adding a US dollar amount with a euro amount when I aggregate this column. And of course, that is inconsistent, that is not logical, right? So therefore, currency also has to be made part of the grouping criteria. And we need to separate the US dollar amounts from the euro amounts. That's why I have put currency also in the grouping criteria. So in my output, I want to see one record for material ZPrinter01 and euro with an aggregated net value amount of 5,000, right? And so on and so forth for the other materials. Let's shift to Eclipse now to build this thing out. So I have here a very basic view entity setup. The name of this view entity is called ZI Sales Summary, and it does a select on my data source VBAP. This is my underlying data source, and I have given an alias to this data source. All right. So now this is how we will start off building our aggregation view, just like you would a normal CDS view entity. All right. So let's start off by telling the CDS view what the grouping criteria is going to be like. We had learned earlier that when we want to aggregate data, we first need to group them into aggregates. And the criteria for grouping the data records is manifested in the grouping criteria, right? So the way to specify your grouping criteria is, so after the curly brackets end over here, you use the keywords group by, and then you specify the names of the columns that are being used to group the data source. So in my case, it is the material number and the currency. So we say sales dot MATNR, that's the material number, followed by a comma. Sales dot currency is yeah, it's this one. So there is an error here. For now, let's ignore it. What I've done right now, I use the keywords group by, and then I mentioned using the alias name of the table. I specified the columns that form part of my grouping criteria, which is the material number, comma, the currency, right? So this is going to be a comma separated list, important thing to note. And also the sequence of columns that you mentioned over here is very important. It must exactly correspond to the order in which you want to group the records, right? So in our case, we want to first group all the records based on the same material number. And within each of those, you want to then group them further based on currency. So the sequence is important. Yeah. So this is how we would specify the grouping criteria. Now this brings us to an important point. Each of the fields that is part of your grouping criteria also has to be made part of your view output, which basically means I need to make these two fields material number also part of my view output like this. So we say sales.material number and then sales.WAERK as currency, right? Now, why is this important? If you think about it, it's quite logical. The view output that we are going to generate out of this is going to have a series of net amounts, and each of those total net amount corresponds to a material currency combination, right? And if you don't see the material and the currency in the output against a particular net amount column, you wouldn't really know for which material currency combination is this net amount, right? So therefore, you should always be able to see the total net amount in combination with the material and the currency to which it corresponds. Um, that's why it makes a lot of sense to have the fields of the grouping criteria also as part of your view output. All right. And now the aggregate function. We want to calculate the total of the net value across all sales orders for this material currency combination. This basically means I want to apply the aggregate function called SUM. The keyword for that is SUM. So let's put a comma first here at the end of the last field. And then the keyword SUM. This is the SUM aggregate function. Open brackets. And then within the brackets, we'll specify the name of the column that we want to aggregate. In this case, we want to aggregate the net value column, which is NETWR, right? So that's the name of the column that we want to aggregate. And this is going to be part of the view output. It's a field in the view output. And so we give it an alias as well. And we say as, all right. Now, there is still an error over here, and let's try to understand what that error is. So the error information that we can see, it says the reference information missing. Now, why does this happen? We know that from the previous videos that whenever we specify an amount field, we also need to specify what is the linked currency code field for that. All right. Now, we are calculating the aggregate of the amount field, but it is still in effect an amount field. And so therefore, it needs to know what is the linked currency code for this particular amount. Now we know that this amount field is linked to this currency field, and that relationship between these two is established using an annotation. So let's encode that annotation in. We say at semantics dot amount dot currency code. Yeah, and the value of the semantic is basically going to be the alias of the reference currency code field, which is currency. All right. Let's save and activate this and have a look at our output. So now you can see the for each material and currency combination, you see just one record in the output. And under the material currency total net value column, you see the aggregated value of the net order value across all sales order items. So let's sort this column based on material number just to verify our results. For the combination of material Z printer 01 and currency EUR, the aggregated total net value is coming as 5,000 euros, right? Now, of course, this can be verified from our data source. Within this aggregate, the aggregated value of the net value column across all sales order item is 5,000. Similarly, for the same material, but the currency USD, the aggregated total net value, what we see here returned by the output is 4,000. And this can also be verified against your data source um, in VBAP. All right. So this is how you apply a simple aggregate function on a data source. The aggregate function that we had taken was SUM. There are other aggregate functions also that can be used. So let's say within each aggregate, so which basically means within each material currency combination, I want to know the maximum net order value. All right. So right now in the first example, what we had done was we found out the sum across all the sales order items within the aggregate. Now I don't want to calculate the sum across all. I just want to know which of those has the maximum value. For that, we can use the aggregate function called as max. And the way to encode that would be we say max. You want to know the max of the column um, sales dot netwr, right? Let's not forget the comma over here, and we say max of the net value column as we say max net value. All right. Now again, this is again an amount column, and so therefore uh, the max of that will also be an amount column, and it needs a reference relationship to a currency, again established using this annotation. All right. So now let's activate this and have a look at our result. So now within each aggregate, you see it finds out what is the record with the maximum net value, and then that maximum net value is printed over here. As an example, let's look at the combination material Z printer 01 and currency USD. The CDS view reports that the maximum net order value was 500 US dollars, and that can be then verified in the VBAP table. All right. So this is the use of the aggregate function max, right? It gives you the maximum of a particular column within an aggregate. And just like you have the function max, you have another function called as min, which you can probably understand from the name itself, gives you the minimum of the column within an aggregate. So let's use that here quickly. Let's look at the output now. So now we have the maximum value being displayed. We also have the minimum value being displayed. All right. Another aggregate function that we will use and we will encounter quite often while developing is called as the count function. Now the count function gives you the number of records within each aggregate. In our case, we had built our aggregates based on the material currency combination. So the count function will tell you how many order items exist within each material currency combination. All right. This is called as the count, right? So count of the records within an aggregate. And the way to use that is as follows. The name of the function is count, right? And within brackets, we put an asterisk and that's it. And we then specify the alias for this field. All right. Save and activate, and then let's have a look at how the output looks. So now you see for each of the material currency combinations, you have this column over here, total item count. It counts the number of records within that aggregate. So let's quickly verify it for the combination Z printer 01 EUR currency. The total item count being reported by the view is 2. This can be verified from the VBAP table. Also for the combination Z printer 01 USD currency, the total item count being reported is 12, which is what we see in the VBAP table. All right. And the next aggregate function that we're going to talk about is quite interesting and also very useful at times. Let's refer to our data source once again. So within each material currency combination, or in other words, we can say within each aggregate, we can see that there are different users who have created the respective individual order items. Yeah? And let's say business wants to know how many unique users have created order items within a particular material currency combination or within a particular aggregate. So for example, for the material Z printer 01 and the currency USD, we can see that there are 12 order items here, But in effect, there are only 3 unique users who had created these 12 order items. Now, the way to achieve this is we use the same aggregate function count, um, because if you think about it, it is in effect a count. That's what you're trying to do. You're trying to count, but you don't want to count all the records, so therefore you don't use the asterisk. Instead, you want to count the unique or the distinct values. So we use the keyword distinct, and then the name of the column whose distinct values you want to know. So the name of the column is the ERNAM, which is the created by. Yes, right. So as you can see, it is similar to the total count syntax. So we use count asterisk for the total, and here also we are counting. So it is the same aggregate function count, but you want to know distinct values of the column ERNAM. So we say count distinct and then the name of the column. And finally, we specify the alias. All right. So let's save and activate. Let's have a look at the output. We can see for the material zprinter01 USD. So for this combination, the unique user count is 3. And this is what can be verified in the VBAP table. Also for the material zprinter01 currency EUR, there were 2 orders in the VBAP table created by 2 unique users. So this is what we see here. So this is how we use the count distinct aggregate function. Finally, we are going to see how to use aggregate functions in expressions. All right. At the moment, I have this column over here. It's called the total item count, right? And it prints out the number or the count of the records within each aggregate, right? I am going to use this count function in an expression. So I say concat with space, and this particular function takes in 3 arguments. The first 2 are the parameters that you would like to concatenate, and then the third is the number of spaces that you would like to see in between them. And the first parameter is going to be the number of records in this aggregate. All right. So this is the first parameter. I say count star, right? And the second parameter I want to see is the string records, and then the number of spaces, which is 1. All right. So this is the function that I'm going to call this the expression. And within that, the 3 parameters, the first is an aggregate function, the second is a string, and then the number of spaces in between them. And then I specify the alias name for this. Let's try to activate this. We see there's an error here. The reason for this error is that the count aggregate function returns a data of type integer, and you cannot use that within this concat function because the concat expects a character. So the way we work around this is let's use the cast operation. So we say cast. I want to cast this particular thing as a character, and character has a built-in data type that I can use, abap.char. I'll specify the length of it like this. Okay. So in case you're not familiar with the cast statement, please have a look at the previous video in this series. We had looked at the topic of cast extensively. So what I'm effectively doing now is I am calculating using the count aggregate function. I'm calculating the number of records in this particular aggregate. I am casting that into a character field of length 20. I am then concatenating that with the key with the string records with 1 space in between, and then I've given it this alias, right? So let's save and activate and have a look at how our output is going to look like. So now we see that for each of the aggregates, the for each of the records, the total item count column. So here, for example, it's 2 is concatenated with the word records, and then it comes under this new column. So we see here the word 2 records, 12 records, and so on and so forth. All right. Now, this is how we can creatively use the aggregate functions as part of different expressions or as part of a function call within a CDS view entity. All right. Let's see another example of how to use a cast statement in an expression. So in an earlier video, we had learned about case statements within CDS views. So now I'm going to incorporate a case statement here, a really simple case statement. Let's say case, let's not forget the comma again. So we say case when the count of the record in an aggregate is greater than 5, then I want to see the phrase more than 5 orders, right? And when the count of uh, records within an aggregate is less than 5, then I want to see lesser than or equal to 5. All right. And I'll end of this case statement and then specify the alias and say order count cutoff. All right. So this is a case evaluation. Um, we had seen case evaluations earlier. And in this case evaluation, we say that when the aggregate function count returns a value which is greater than 5, which basically means when the number of orders in that aggregate is greater than 5, then the keywords more than 5 orders should be printed. And when it is lesser than or equal to 5, then the phrase less than or equal to 5 would be printed. All right. Let's have a look at our output here. So we can see that the order count is evaluated, and if it is less than 5, for example, here the phrase less than or equal to 5 appears, and when the number of records in that particular aggregate is more than 5, then the more than 5 orders phrase appears. So this is how you can creatively use aggregate functions in your data modeling as part of expressions within a CDS view. All right. I hope the concept of SQL aggregate functions in CDS views is now clear to you. Just to summarize, your data source returns a set of data records. Your CDS aggregation view groups those records into collections. Each of those collections is called as an aggregate. You use a certain grouping criteria to build up these aggregates. In our case, the grouping criteria was the material number and the currency. Once you have your aggregate built up, you then have a column that you want to aggregate, and that column was referred to as the aggregated column. And on this column, you apply a what is called as an aggregate function. We have different kinds of aggregate functions. We had seen examples of those: the sum, the max, the min, count, and then the variation of the count, which was a count distinct. And we had also seen that these aggregate functions can be creatively used as part of expressions as well. We had also learned that all the fields that are in the grouping criteria should be made part of your view output as well, and that the sequence of fields that we mention in the grouping criteria, the sequence has to be built correctly. In the next video, we will be learning about associations within CDS views. Until then, keep coding and goodbye.